We go to the first subtopic, 3.1, area under a curve and between two curves. For this subtopic, we have region bounded by a curve and the x-axis, we have region bounded by a curve and the y-axis, and last we have region bounded by two curves. First, we look at region bounded by a curve and the x-axis. Here we have three diagrams. The first one, to find the area, we just integrate function y or fx from a to b. Second diagram, we have function y equals to gx. So to find the area, we just integrate function y from a to b. But the region is below the x-axis. So when we integrate this function, we will get negative answer. But area cannot be negative. So we need to put modulus to get positive answer. And the last diagram, we have two regions. So to find these two regions, we need to integrate one by one. First, we integrate from a to m, and then plus we integrate from m to b. But region from m to b is below the x-axis, so we put modulus. Example number 1a, find the area of the region bounded by y equals to negative x squared plus 8x minus 12, x equals to 3, x equals to 5, and the x-axis. Okay, to find the area, first step we need to sketch the graph. This function is quadratic function. Okay, so we sketch graph for quadratic. This quadratic is negative x squared, so the graph is set. So we need to find maximum point. To find maximum point, we use formula x equals to negative b over 2a. b is 8, so negative 8 over 2 times a is negative 1. Then we solve, we get 4. Okay, to find y, we substitute 4 into function negative 4 square plus 8 times 4 minus 12. Then we solve, we get 4. So our maximum point is 4, 4. Okay, next we find the intercept x, y. When x equals to 0, we substitute into y, then we get negative 12. Then when y equals to 0, we factorize this equation, then we get 2 and 6. Okay, now we sketch the graph. We put maximum point 4, 4. This one is maximum point. Okay, when x equals to 0, y equals to negative 12. So come from here. Okay, set. Okay, this one is negative 12. And the intercept is 2 and 6. Okay. Okay, finish. Sketch graph quadratic. And we have line x equals to 3 and x equals to 5. This one x equals to 3 and this one x equals to 5. Okay, find the area of the region bounded by quadratic. Line x equals to 3, line x equals to 5, and the x-axis. So the area bounded here. Line x equals to 3, line x equals to 5, curve, and x-axis. Okay, now we want to find the area. So area, we just integrate function y, negative x squared plus 8x minus 12 dx from 3 to 5. Okay, then we integrate. We get negative x cubed over 3 plus 8x squared over 2 minus 12x from 3 to 5. We simplify. We get negative x cubed over 3 plus 4x squared minus 12x from 3 to 5. Then we substitute value 5 and 3. Negative 5 cubed over 3 plus 4 times minus 5 square. Then minus. Then we solve, we get 22 over 3 unit square. Okay, since area, so we put unit square. Example number 1b, find the area of the region enclosed by the curve y equals to 2x square minus 5x minus 3, the x-axis, the y-axis, and x equals to 2. So first step, we sketch the graph. Function is quadratic, and this one is positive x square, so smile. First, we find minimum point. Use formula negative b over 2a. b is negative 5, and a is 2. So we get answer 5 over 4. Then we substitute x into y. Then we get answer negative 49 over 8. So we conclude minimum point is 5 over 4 and negative 49 over 8. Next, we find the intercept. X, y. When x equals to 0, then we get y negative 3. When y equals to 0, we factorize the function. Then we get negative 1 over 2 and 3. Okay, now we sketch the graph. We put minimum point 5 over 4. So minimum point. And put the intercept negative 3, negative 1 over 2. So I sketch first. Okay, then put negative 3, negative 1 over 2, and 3. Okay, finish, sketch the quadratic, and we have line x equals to 2. So we put here x equals to 2. Okay, now we find the region closed by quadratic, by curve, x-axis, y-axis, and x equals to 2. So this one is y-axis, x-axis, x equals to 2, and curve. So the region is here. Okay, now we find the area. So we need to integrate from 0, from here to x equals to 2. So here is 0. So from 0 to 2. And function y, 2x square minus 5x minus 3 dx. Okay, since the region below the x-axis, so we need to put modulus. Okay, now we solve, we integrate, then we get 2x cubed over 3 minus 5x squared over 2 minus 3x from 0 to 2. Then we substitute value 2 times 2 cubed over 3 minus 5 2 squared over 2 minus 3 times 2. Okay, minus we substitute 0, then we get 0. We solve, we get answer modulus negative 32 over 3. Since modulus, so our answer is positive 32 over 3 unit square. Example 1c, find the area of the region enclosed by the curve y equals to x square minus 4 and the x-axis from x equals to 1 to x equals to 4. Okay, first step, we sketch the graph. Function is positive x square, so the shape is smile. Since smile, so we find minimum point. So we use formula negative b over 2a. Doesn't have b, so our x is 0. Then we substitute into y. So we get 0 minus 4 equals to negative 4. Then we conclude minimum point is 0, negative 4. Then we find x and y intercept. And y. When x equals to 0, y negative 4. And when y equals to 0, we factorize, we get plus minus 2. Then we sketch the graph. We put the minimum point 0, negative 4. So here, negative 4. So our graph, positive 2, negative 2. Okay, then we have line from x equals to 1 to x equals to 4. Which one? X equals to 1 and x equals to 4. X equals to 1, x equals to 4. Okay. Now we want to find the area of the region enclosed by curve, x-axis, line x equals to 1, line x equals to 4. So we have two regions. in curve x equals to 1, x equals to 4, and x axis. So we have two regions. Now we find the area. First area, we integrate from 1 to 2. Function curve x square minus 4 dx. We plus integrate from 2 to 4. Function is x square minus 4 dx. The first one is below the x axis, so we put modulus. Then we integrate. We get x cubed over 3 minus 4x from 1 until 2. Then we plus integrate x cubed over 3 minus 4x from 2 to 4. Then we substitute value 2 cubed. We solve, we get 5 over 3 plus 32 over 3. And last final answer, we get 37 over 3 unit square.